Rectangular coordinate system, parts of the coordinate plane and order pairs. And an order pair is an x and a y. The horizontal axis is known as the x-axis, and the vertical axis is known as the y-axis. And where the two lines cross or intersect is a point, and that point is known as our origin. Now, the coordinate plane is broken down into quadrants. Our first quadrant is known as the x value, y value are positive. So the first quadrant, if you notice the x-axis, the values are positive, and on the y-axis, when you go up, the values are positive. So in the first quadrant, my x's and y's are positive values. The second quadrant, we go counterclockwise, is going to have a negative x value, because look at the x-axis. My x values are negative and the y values are positive. It's going up. In the third quadrant, both my x values and y values are negative. When you look at the axis, you see my x-axis has negative values, my y-axis has negative values. And then lastly, the fourth quadrant, my x values are positive and my y values are negative. So when we want to graph or plot an order pair or a point, we're going to always start at the x value. So you look at the x coordinate and you're going to look for it on the coordinate plane. You always want to start at the origin, and because the x value in this case is a positive 5, I'm moving to where x is a positive 5. Now you're not plotting the point there. You have to find the y value from your x value. So I go to where x is 5, and then I find the y value, and it's a -2, and because it's -2, I'm going down to where y is -2, and I plot the point. So my 5, -2 would be on the coordinate plane where it's located in this picture. When we're asked to complete an order pair, you're using evaluation to solve for the missing variable. So when you have an order pair, remember an order pair is always an x value first and then a y value. So in this case, I'm given a variable in the x spot and I'm given a value for y. So to find the variable x, I have to substitute the y that's given into the equation. So when I substitute it in, be careful because we have a -y, which is going to make that a double negative because the value given is a -6. So that double negative will change to a plus, and then I have a two-step equation. So in a two-step equation, you're going to subtract that 6 first, and then you'll divide through by 3. And for this order pair, my x value would be 2 for this equation. So again, another example, I'm given my x value now and I have to find my y value. So I'm going to take the value that's given for x, I'm going to substitute it into the x value of the equation, and then I'm going to find my y. So 3 times 0 is 0, so I'm going to be left with a -y equals 12. And I need to divide through by a -1, and I'm going to get my y value equals a -12. Pause and try. So in this case, you're given your y values -4. You evaluate. You have a two-step equation. You're going to add 12, then divide through by 2, and you end up with your x value equals 9. Pause and try. So you're going to substitute the 0 in for x. 2 times 0 will go away. You're left with 3y equals 6. You divide through by 3 and you get y equals 2. So one way of graphing an equation is to use a table of values. And what a table of values is, it's made up of 2 columns and it lists x values and their corresponding y values. So let's do an example. Now notice here that the equation uses f of x equals 2x minus 1. Well, f of x is a notation for functions, and function notation uses f of x, but it also is equivalent to the variable y. So it's good to get familiar with f of x and f of x also being a y value. So when I'm doing a table of values, instead of having f of x, I'm going to use y. And my x values, I'm going to choose my own x values. Now when I choose my x values, I like to choose a negative x value, I like to choose 0, and I like to choose 1 so that I know what's happening on all sides of the coordinate plane. You want to know what's happening on the negative side of the x-axis, you want to know what's happening at the origin, and you want to know what's happening on the positive side of the x-axis. So what you're going to do with your x values is you're going to substitute it in to the equation given, and you're going to find your y value. So I started off with x negative 1. I'm plugging it into the 2x minus 1. So I have 2 times a negative 1 minus 1. And that's going to be a negative 2 minus 1, which will give me a negative 3. And then I'm going to plug in 0 into the function. And I'm going to have 2 times 0 minus 1, which would be a negative 1. And then I'm going to plug in that positive 1, and I'm going to evaluate, and I'm going to get 2 minus 1 will be 1. So I chose the value of x, and then I'm finding what y would be for that value of x. Now that I have my table of values filled out, I can create my order pairs. And remember, the order pairs are the points that you will be plotting on the coordinate plane. And it's made up of the first value is your x and the second value is your y. So you're going to take these order pairs and you're going to plot it on the coordinate plane. And you notice here that I have a negative 1, negative 3, that's my first point, and I plotted the point. And then I had 0, negative 1, that's my second point that I plotted, and 1, 1, and I plotted my third point. Once you have your points plotted, now you're just going to draw the graph, and in this case it ends up being a line. So this is using a coordinate plane, or using a table of values to graph an equation. Pause and try. So in this case, you should have gotten negative 1, 4, 0, 1, 1, negative 2 as your order pairs. You plot the order pairs and then you draw the line. So when we talk about equations, one type of equation is called standard form. And what standard form is when you have x plus y equals some value c. And the coefficients of x and y and c are integers. So an example here of standard form would look similar to this. 2x plus 3y equals 6. This is standard form. Now some definitions. X-intercept is where the graph crosses the x-axis. Now what I need you to understand about the x-axis is for any order pair that has a point on the x-axis, well, all the y values on the x-axis would equal 0. So to find the x-intercept in an equation, you'll set y equal to 0 and then solve for x. So your order pair would have an x value because it's on the x-axis, and our y value will be 0. So the y-intercept is where it crosses the y-axis. So if it's on the y-axis, every value of x on the y-axis is equal to 0. So when you're trying to find the y-intercept in an equation, you'll set x equal to 0 and solve for y. So the order pair would have 0 in the x spot and a y value that you've found. So let's do an example here. We're going to find our x-intercept and our y-intercept for this equation 2x minus 3y equals 12. So to find my x-intercept, remember the y value for my x-intercept will equal 0. So I'm going to have an order pair where I'm going to have an x value and the y value will equal 0. So I'm going to substitute 0 into the equation and I'm going to solve for y. Substitute. So let's do an example. We want to find the x and the y-intercept. So to find the x-intercept, I'm going to start with finding the x-intercept. The order pair is going to end up being x comma 0. So remember, 0 is in the y spot. So you're going to do the evaluation by substituting in 0 into the equation. So I substitute 0 into this equation, that 2x minus 3y equals 12. I plug 0 into y, and I'm going to have 2x minus 3 times 0 equals 12, and 3 times 0 is 0. So I'm left with 2x equals 12, and now I can solve for x. I divide through by 2, and I end up with my x value is 6. Now be very careful because you can't leave your answer as x equals 6. You have to write it as an order pair because when we're talking about intercepts, they are a point that will be plotted. And in this case, because it's the x-intercept, it will be plotted on the x-axis. So it's very important that you write your answer as an order pair. Now when we talk about the y-intercept, again, the x value will be 0 and you will find your y value. So I'm going to plug in 0 for the x in the equation. I'm going to evaluate, and 2 times 0 is 0, so I'm left with a negative 3y equals 12. And now to solve for y, I divide through by that negative 3, and I get 12, or y equals a negative 4. And just like the x-intercept, the y-intercept needs to be written as an order pair. And the x value is 0 for the y-intercept, so you're going to end up with 0, negative 4. These are the intercepts for this equation 2x minus 3y equals 12. Pause and try. So again, for the x-intercept, I plug in 0 for y, and I end up having a negative 2x equals a negative 8, and I get parentheses 4, 0 as the order pair. My y-intercept, I plug in 0 for x, I'm left with the negative y equals a negative 8, and I solve for y, I get y equals a positive 8, and the order pair would be 0, 8. So please remember to write your solution, your intercepts, as order pairs. What you'll be doing with these intercepts is you will be graphing the equation. So when you're graphing an equation of a line, you can find the x and y intercepts, and then you're going to plot the x and y intercepts on the coordinate plane. And remember, the x-intercept will be on the x-axis, your y-intercept will be on the y-axis, and then you'll draw the line. So let's see what this looks like. So we have this 2x minus 3y equals 12, and in the previous example we found the x and the y-intercept to be 0 or 6, 0 for my x-intercept, and my y-intercept was 0, negative 4. I'm going to take these two intercepts and I'm going to plot them on the coordinate plane. Remember, the x-intercept will be on the x-axis, which will be 6, 0. My y-intercept will be on the y-axis, which is that 0, negative 4. Make sure you're plotting them on the right axis, and then you can draw your line and you graph the equation of the line using your x and y intercepts. Pause and try. So again, you're finding your x-intercept. It should be 6, 0, and your y-intercept is 0, 8. When you plot these points, make sure you're plotting them in the right position. Your x-intercept is at 6, your y-intercept is at 8, and you graph the line. Slope describes the steepness of a line. The symbol for slope is a lowercase m, so mathematically we'll be using m to represent slope. So when we're looking for the slope of the line, from one point to the next point, we'll be looking for the vertical change, or our y values, over the horizontal change, or our x values. So when you're given a picture of a line, you're going to find two distinct points, and in this case we are given them, and you're going to count how far off horizontally the one point is to the other, and how far off vertically the one point is from the other. So finding the slope of this line, so it's going to be m equals, and I'm going to find my horizontal change by going from the one point and counting how far horizontally it is from the second point, and I see that it's 2 spaces away, so the horizontal change, or my x values, is 2. And now I'm going to count my vertical change, and I'm going to see that it goes up 3, so the vertical change is 3. So the slope for this line would be 3 over 2, or 3/2. When we're looking for slopes and determining whether a slope is positive, negative, 0, or undefined, you always want to look from left to right. So you always want to look at the graph from left to right. So in a picture, if we're looking from left to right and it slants upward, it's a positive slope. So when we look from left to right, the slope is positive when it goes up. When the slope is going down, the slant is down from left to right, you always want to look the way you read, it is a negative slope. So a slope up is positive, a slope down is negative. Now when you have a horizontal line, so a horizontal line, we have 0 as our slope. So 0 would be the slope, and a vertical line has an undefined slope. So these are really important. When you're looking at a graph to determine if it's a positive or negative slope, look from left to right. If it's going up, it's positive, down, it's negative. Now horizontal lines is a slope of 0, and a vertical line is an undefined slope. So this is very important to remember. So I am giving you this little guide to help you to remember, and this is the Mr. Slope guy, and what it does is it kind of shows you in the face what we're looking at. So a positive slope is that plus for the eye, and the wink is my negative slope, and then the nose here represents my vertical, which is the undefined, so you see that U there, and then my vertical or my horizontal is my zeros or my dimples for the guy. So this is a way of remembering your slope of a line and whether it's positive, negative, undefined, or 0. So when we want to graph a line given a point and a slope, we're going to be doing the reverse. So I'm going to take this point and I'm going to plot it. So we have a point which is 0, 4, and I plot it. So anytime you have a point, you can at least start by plotting the point. Now I have the point plotted, and I need a second point in order to graph the line. So I'm going to use the slope of the line to be able to find the second point. So remember that my slope is my vertical change over my horizontal change. And when we have an integer, in this case I have a -3, I'm going to end up having a -3, but remember, any integer or whole number can be you can create a fraction from it by putting it over 1, so that you can get your horizontal change. So your vertical change is the -3, and your horizontal change is 1. Now when you have a negative slope, you always want to move down along the y-axis to represent that it's negative, and you always move to the right for the horizontal change. So in this case, I'm going from where the point was plotted, and I'm going to just count down 3 for my vertical change, and then I'm going to count from that spot over my horizontal change, which is 1, and then I'm going to plot my second point. So to find the line given a point and a slope, first plot the point, then use the slope. And remember, it's the vertical change over the horizontal. And if the slope is negative, put the negative with the vertical change and move down, and always move to the right for the horizontal change. Now I can just graph the line, and I have the picture of the line. Pause and try. So again, you're plotting the point, and you're using your slope, and you have your vertical change and your horizontal change because you have a fraction, and because it's positive, your vertical change will go up 2 and your horizontal change will go over 3 to the right, and you plot your point, and now you can graph the line. So when we talk about the slope-intercept form, that is when we have it y equals mx plus b. We have our equation solved for y. Now notice here I have m next to the x value, or the x variable. Well, m again represents the slope. So when you have m, the coefficient of the x is always going to be my slope for the equation, or the slope-intercept form. So the y equals mx plus b, the coefficient of x is my slope, and keep in mind that the slope-intercept, we need the intercept, and it's going to be my y-intercept, and the y-intercept will be the b value. Because remember, my y-intercept is where x equals 0, and if I were to plug in 0 into this formula, you would see that I would have m times 0, and that would go away, and my y value would equal b. So therefore, when it's in slope-intercept form, y equals mx plus b, I'll have my slope, the coefficient of x, and I'll have my intercept, my point, 0, b. So you always have a point when you have it in slope-intercept form. Now notice here that we could also have it written in function notation, where we would have f of x equals mx plus b. F of x and y are the same thing. So f of x is function notation, but also means y. So in this equation, y equals 1/2 x minus 3, we're asked to identify my slope and my y-intercept. In this case, it's already in slope-intercept form. So my y, or my slope, is going to equal the 1/2, or the coefficient of x. My y-intercept, if I plug in 0 for x, is simply going to be a -3. So the order pair for my y-intercept will be 0, -3. Pause and try. So your slope here is a -2, and your intercept is going to be 0, 1. Pause and try. So your slope here is equal to 1/2, and your intercept, be careful here, because the plus or minus, there's no plus or minus, that means that the intercept would be 0, 0. So at the origin. So when you're asked to graph the equation of a line, and it's in slope-intercept form, you need to identify the slope and the intercept. And once you have the slope and the intercept, you plot the intercept, and you use the slope to find the second point. So we have identify your slope, and your slope is 2, and your intercept, or your b value, is a -4 because it's -4. So the intercept point would be 0, -4. So now you're going to plot that point, that intercept, which would be on the y-axis at -4. So we have 0, -4. And then you're going to use your slope to find your second point. Now remember, when you have a slope and it's an integer, you're going to put that integer over 1 so you have that horizontal movement. And because it's positive, we're going to move up 2 from that intercept and over +1 and plot our second point. And now I can graph the line, and this is the graph for y equals 2x minus 4, using the slope and the intercept to graph the line. Pause and try. So again, my intercept is 0, 1. My slope is equal to a -2. I always put the negative with the vertical movement, and my horizontal movement is +3. I plot the point. I go down -2 over +3 to the right and graph my line. Finding the slope and the intercept of a line. In order to find the slope and the intercept of the line, we have to have the equation in SlopeIntercept form, where it's y equals mx plus b. So in this equation, 2x plus 6y equals 12, I need to solve the equation for y. So to solve for y, you want to first get rid of what's around it versus what's attached. So I want to move that 2x to the other side of the equal sign. And to move it, because it's positive, I'm going to subtract 2x from both sides. So I'm going to be left with 6y equals a -2x plus 12. And the reason why I'm putting the -2 next to the equal sign is because I want it in slope-intercept form. And the x variable is next to the equal sign. So now I have to get rid of what's attached to the y, which is that 6, and to get rid of it, I need to divide. Now remember, you have to divide everything on the other side of the equal sign by 6. So when you're dividing, I'm dividing everything on the other side of the equal sign, and I'm left with y equals a -1/3 x plus 6. So I reduce the -2/6 to -1/3, and I reduce the 12 divided by 6 to 2. Now I can identify my slope is a -1/3, and my y-intercept in this case would be 0, 2. Pause and try. So you're going to find your slope-intercept form. You're going to subtract 5x from both sides. You divide through by a -3. You're left with y equals 5/3 x minus 4. And now we can graph it. We're going to graph by using the slope and the intercept. I plot my intercept, and then I'm counting 5 up and over to the right 3, and I graph my line. So now when you're given an equation and it's just y equals some number, well, when it's y equals some number, the slope is going to be 0. And when the slope is 0, remember, when the slope is 0, it has a horizontal line. So when you're doing this, you're going to go to where the y value is, and you're going to draw a horizontal line. So a way of remembering this is that y creates a horizontal line, or the horizon, so that when you're doing a y equals some number, you're going to go to the y value and you're going to draw a horizontal line. So when you have an equation that has x equals a value, some number, a, it's undefined, our slope. Our slope is undefined. And when our slope is undefined, we have a vertical line. So another way of remembering this is if you have x equals a number, x can kind of create a horizontal or a vertical line, and that vertical line is what the picture is going to look like. So let's see an example. We're asked to graph the equation of the line y equals a -2. The slope of y equals a -2 is equal to 0. So when the slope is 0, That means that I'm going to have a horizontal line. I go to where y is -2 and I draw my horizontal line. My next example is when I have x equals a number, and in this case x equals 1. I need you to understand that when you have x equals a number, the slope is undefined. When the slope is undefined, we have a vertical line. So you're going to go where x is 1 on the axis and you're going to draw a vertical line. Pause and try. The slope here is 0. We're going to have a horizontal line at -5. Pause and try. The slope here is undefined. We're going to have a vertical line where x is 5.